Using the data from the previous example, use Chebyshev's theorem to, part A, determine the percentage of patients that have serum HDL within 3 standard deviations of the mean. Round to 1 decimal place as needed. The empirical rule and Chebyshev's theorem are just two different ways to estimate what percentage of the data is within a certain number of standard deviations. We don't have a picture for Chebyshev's theorem like we do the empirical rule, so we will just draw a line with mu plus sigma, mu plus 2 sigma, so on and so forth. We are wanting to determine the percentage of patients that are within 3 standard deviations of the mean, so that's between here and here. If we use the empirical rule, we would get 99.7%. However, Chebyshev's theorem will give us a different number. Let's recall Chebyshev's theorem. Chebyshev's theorem says that for any data set or distribution, at least 1 minus 1 over k squared times 100% of the observations lie within k, standard deviations of the mean. So our k is 3 because we're wanting to know how many are within 3 standard deviations of the mean. So now we will substitute 3 for k in the formula. Put this in your calculator, and when we round to 1 decimal place, we get 88.9%. Part B, determine the actual percentage of patients that have serum HDL between 22 and 92.8 or within 3 standard deviations of the mean. If we look at the raw data, we will find that 100% of the data is between 22 and 92.8. So we get 88.9 using Chebyshev's theorem. 100% is the actual percentage, and if we had used the empirical rule, we would have gotten 99.7%.